Hello everyone, Mr. Stevens here with another lesson on trigonometry. This time we're going to be looking at something called angles of elevation and depression. And basically this is another way we can apply our knowledge of trigonometry to solve practical problems. They're just sort of housed in this disguise of these new words, angles of elevation and angles of depression. The actual trigonometry that we're going to be doing is not any different to what we've been doing before. The difficulty here is translating the information in the question into a triangle. And I think this is even more so than the previous lesson, practical trigonometry problems. For some reason, my experience has been that these angles of elevation and depression are a significant point of difficulty for students in trigonometry units. But I really don't think it needs to be that way. And I hope you agree with me once you see what they are. So basically, this is what we're talking about when we're talking about angles of elevation and depression. We have a straight horizontal line, and if you look up, that's an angle of elevation. If you look down, that's an angle of depression. So I want you to put yourself in this position here whenever you're doing these problems and think, would I be looking up or would I be looking down? If the answer is up, we're talking about elevation. If the answer is down, we're talking about depression. I think you'll see what I mean a bit better by that when we jump into an example. So let's do that. This is another way it can be written. An important thing I want to note actually from this diagram is these are parallel lines. This symbol here tells us that. Something we should remember about parallel lines is if we can make a Z, that is a very poor line. If we can make a Z out of these two angles, it means they're equal. So if we're given an angle of elevation or an angle of depression, it can be useful to remember that if you can make this kind of shape, that you know that the two angles are equal. All right, let's jump into an example. I'm going to do this one. I don't want you guys to worry about writing anything down. Just watch what I'm doing. So a park ranger measured that when she looked up from the ground at the top of a volcanic plume, the angle was 41 degrees. She looks at a map and she realizes that she's 7 kilometers away from the base of the volcano. She wants to calculate the height here of the plume. So we need a h over here that we're going to find. Now let's think back to our adjacent opposite hypotenuse. Which one do we need? SOHCAHTOA. We've got opposite and we've got adjacent. I have written these the wrong way around. I'm sorry, guys. Opposite is over here. Hypotenuse is here. Sorry about that. So the ratio that we're going to need for this question is tan. Tan 41 equals the height of the plume divided by the adjacent side, the distance away from it. We get h by itself by timesing by 7. We put that answer into our calculator and we come out with 6.085 ... If we're going to answer to 2 decimal places like the question asks, we round that off to 6.09 kilometers. So the only difference here between this question and one that we did in our last lesson is that instead of just being told that this angle is 41 degrees, we've used this new language, angle of elevation. I didn't tell you she was looking up at the top of the volcanic plume. I told you that there was an angle of elevation. So you need to remember in your head that an angle of elevation means that she's looking up. Let's do another one. I'm going to do this one. This time we have our friend standing at the top of a cliff. The cliff is 42 meters tall, so let's start drawing the picture. The cliff is 42 meters tall. We're standing at the top of it. Now, down the bottom here, there is a boat 90 meters away. Oh, this was 42 meters, by the way. There's a boat out here that's 90 meters away from the base of the cliff. And we want to know the angle of depression to the boat to the nearest degree. So if we're standing up here, 42 meters above sea level and 90 meters horizontally away from the boat, and we look down from the horizontal out to the boat, that's the angle of depression that we've made. Now, this is a really important point, guys, that tends to trip a lot of students up. This is not the angle of depression here. The angle of depression is looking down from the horizontal. That is this angle here. So if we want to find that angle, remember, the one we need to look at is this one, because these two angles are exactly the same. We can't use any trigonometry to find this angle up here because it's not part of our triangle, but we can use it to find this one here. You might be clever enough to notice that we could just actually make the same triangle here if we needed to, because this distance is also 42 meters and this distance is also 90 meters. If you could spot it that way, that's fine too. I think it's easier to just remember that these two angles here and here are the same. Either way, I'm going to call the angle theta. We have the opposite and adjacent. So we're using tan theta equals, sorry, that should be opposite 42 over 90. See, I didn't write down my OA and H and I made a mistake. That's why it's always good to write those down. Now we need to do tan to the minus 1. We put it in our calculator. Tan minus 1, 42 over 90. The answer is 25.0168. We're answered to the nearest degree, so it's 25. Right, moving on. Here's one for you guys to do with me now. Angle of elevation looking up to the top of a tower up here is 28 degrees. And the distance from the base of the tower to where we are is 30 meters. Find the height of the tower. What sides of the triangle are we dealing with? Opposite and adjacent. So we're going to do tan 28 equals opposite. Let's call this x. X over 30. Remember, when the x is on the top, we times by the number on the bottom. X equals 30 tan 28. That goes in the calculator. We get 15.9512. And to the nearest meter, that's 16 meters. A note on this, I would not really expect you guys to do this bit of working out every time. I'm happy for you to just go from writing down tan 28 equals x over 30 to then writing down x equals 30 tan 28. I want that part of this process to become fairly automatic for you. Right, here we have another example where we're standing on the top of a cliff. We have a boat out to sea, and we want to know how far the ship is from the base of the cliff. The cliff is 85 meters. We have an angle of depression of 17 degrees. So that means, remember, that it's not this angle that's 17 degrees. it's this angle or this angle that's 17 degrees. And we want to find the distance to the ship. So what sides have we got? We've got opposite, we've got adjacent. So we need to use tan. Tan 17 equals opposite 85 over adjacent, which is x. Remember, in this situation where we have the x on the bottom, we're just going to swap places with the trig. Now we've got x equals 85 divided by tan 17. And the answer we get there is 278.022 to the nearest meter is just 278. Now, okay, in part B, we're also asked to find the distance in a straight line from the top of the cliff to the ship. So now we're looking for our hypotenuse. We could either use adjacent and hypotenuse and cos, because we know what x is now, but because x is a really messy decimal, I think it's better to use sine and use opposite over hypotenuse. Because we know what sine is, we know what the opposite is, sorry, and it's a whole number. Again, we've got the opposite on top and the h on the bottom. So remember, we just swap everything around. That one goes in the calculator. And it comes out to 290.7258, or to the nearest meter, 291. All right, now time for you guys to practice on your own. We should be super comfortable with using the trig functions now. We're just going to need to take a second to think about what the questions are actually asking us. But yeah, once you finish that, make sure you check back in with the success criteria. Make sure you're able to correctly translate the information from the question into something you can work with, and then apply your trig knowledge to find the angle or the side, whatever it is that the question is asking you to do. So you guys can go get started on that now. Thanks, guys.